So more types of equations that we haven't covered yet here in chapter 1 are radical equations. So where we have a square root. Now we have used square roots to solve, right? If we have something like x plus 3 squared equals 9, right? We know to get rid of the squared here, we would have to do the opposite, which is the square root. So we do the square root of both sides. We'd say x plus 3 equals positive or negative root 9 is 3. We would subtract 3. And then this would still give us two answers, right? We got the negative 3 plus or minus 3. And then this would break apart into 2. Negative 3 plus 3, which is 0. And negative 3 minus 3, which is negative 6. So this is one case where we've used square roots. So we're going to do the opposite then. If we're given the square root, we're going to square it to undo that square root because they are inverses of each other. So we have a square root, but before we can square, we need to isolate the square root. So we need to move anything away from it that's not underneath, and that in this case is a minus x. So we're going to add the x over first. Then we have only the square root left on that side. We've got an x plus 2 on the other. Now we can go ahead and square both sides. And notice how I'm putting that x plus 2 in parentheses and squaring it. And then now we have the square root squared, which are inverses. So those cancel each other out. We're left with 2x plus 7 on this side. And then we do need to multiply out and square the x plus 2. Remember, x plus 2 squared means we write it twice. We do not just take x squared and 2 squared. It is not the same thing. So now we have an equation to solve. I'm going to go ahead and multiply out on the right side. So 2x plus 7 stays the same. Here we'll do x squared plus 2x. And then plus 2x plus 4. Combine some like terms. And then get it set equal to 0. So I'm going to subtract 2x and subtract the 7 under their like terms. So now we've got 0 equals x squared plus 2x minus 3. And then at this point, when you have your quadratic, there are a few ways that you can solve this one. You could try and factor. Maybe it factors, maybe it doesn't. You could do completing the square. Or you could use the quadratic formula. Remember, the quadratic formula works every single time, no matter what. On this one, it's not telling us which one to use, but I do recognize that this one factors. So I could do two sets of parentheses here. It's set equal to 0. We can do x, and then we can do a positive 3 and a negative 1. But if you don't want to think too hard about the factoring and you just want to do the quadratic formula, you certainly can. It works every single time. And then this will give us our two answers. X plus 3 equals 0, and x minus 1 equals 0. So we're really combining a lot of skills on this one, which is great review. So our two answers are a negative 3 or a positive 1. All right, letter B. Now this one would be a little bit easier if it was set equal to 0, but we can still work with it, and we're still going to get, we have two different square roots here. We're going to get each one on different sides. So right now they're on the same side of the equal sign. So let's go ahead and add over the square root of x minus 3. Okay, so then we get the square root of 2x minus 5 equals, and I can just write this as 1 plus the square root of x minus 3. Now at this point, we just need to go ahead and square both sides. We need to get rid of the square root. Now we have two terms over on the right again that we need to square. So again, over on the left side, that square root's just going to cancel out with the squared. But here I have a binomial, and I need to write it out twice. Okay, so now we need to multiply that together. So we get 1, and then plus root x minus 3, and another positive root x minus 3, and then root x minus 3 times root x minus 3. Those square roots cancel each other, so it's just plus x minus 3. Now let's combine some terms here, and I know I'm working into my other problem. I'll have to just go around it. So we've got 2x minus 5 equals, and now I can combine the 1 and the minus 3. So that's negative 2. And then we can combine the roots. Those are the same, and there are 2 of them. So it would be plus 2 root x minus 3. And then we've got this plus x. That's just going to stay. And let's go ahead. We still have a square root. So now we need to get this square root all by itself. So I'm going to, just so you don't have this extra example here to look at, let's go ahead and erase that. All right, now we've got some more room to work. So now we're going to isolate the square root of x minus 3. So let's subtract this x over to its like term, and let's add the 2 over to its like term, and that'll give us an x minus 3 equals 2 times the square root of x minus 3. That's gone. Now you could divide by 2 on both sides here, but that's going to give you fractions. So let's go ahead, because these are multiplied, this is one term, we can go ahead now and square both sides to get rid of the square root. So that'll give us x minus 3 times x minus 3 equals, and then we just need to make sure we square the 2. So 2 squared is 4, and then the square root squared is gone, so that's x minus 3. All right, let's simplify. Now I'm going to give you, oh, no, we're not, because that would divide off an answer. I was going to divide both sides by x minus 3, but remember, we do not want to divide off answers. So that brings up a good point of something we should not do, because you never want to divide off answers. We want to include all of them. So let's go ahead and multiply out. Here we're going to get x squared minus 3x plus 9 equals, and then we can distribute the 4 and combine like terms. So move the 4x over to these two x values, and then add the 12 to the 9. So we have 3 x values here. That gives us negative 10x. And then combining 9 plus 12 plus 21 equals 0. And again, you have completing the square, quadratic formula, factoring if you can. This one does factor. Multiply to 21, add to 10, 3 and 7, but we need negative 10 and a positive 21. So both will be negative, and we can get our 2 answers from here. So 3 and 7, both positive. So this was a 2-step. We had to square both sides twice. That's okay. It's just more algebra that you're working with. Just be careful when you do that and make sure you're checking your answers as you go. All right, now here we have a cubed root for example C. And we can go ahead and get rid of that by cubing both sides instead of squaring both sides. But first we need to add over the 5. So here's what that looks like. Now, because this isn't a square root, this is a cubed root, we're going to do both sides to the 3rd power. To the 3rd power. That cancels out your cubed root, so we get 3x plus 1, and then 5 to the 3rd power. 5 times 5 times 5 is 125. And then in this case, we have a pretty simple equation to solve. Subtract 1 and divide by 3. Now in this case, you do get a fraction, and that is okay. Please leave your answer as a fraction, not as a decimal, because when you have decimals, you have to round them off. And in this case, it would stay 124 over 3, or you could write that as a mixed number, and that would be 41 1/3. But please leave fractions. Don't write 0.3 because that would be rounding, and we don't want to round if we don't have to. All right, and then example 6 is a review of rational equations, because we've done rational equations already in chapter 1, but it's always a good thing to remember and to review. So rational equations have denominators. So to solve and to simplify these, basically to get rid of the denominators, we want to multiply by the least common denominator. So in this case, in the denominator, we have an x and we have an x minus 2. So both of those have to be included in our least common denominator because they're different. And then we multiply each term by that. So I'm going to multiply the 2 times an x and an x minus 2. Same thing with the 3. Same thing with the 1. And then we should be able to cancel out all of the denominators. So in my first term, the x's cancel. So I'm left with 2 times x and 2 times negative 2, negative 4. Then we have our equal sign. In the second term, our x minus 2 values cancel, so we're just left with 3 times x, so 3x. And then in our last term, nothing cancels, so we're left with a negative 1x, and then still has to be multiplied by x minus 2. Now we have a nice equation that we have no more fractions and we can just solve for x. So let's see what we get here. 2x minus 4 equals, distribute negative 1x, so it would be negative 1x squared, and then negative 1x times negative 2, positive 2x. And then we have an x squared, so let's get everything on one side, and I'm going to make this, I want this x squared to be positive, so I'm going to move everything from the right side over to the left side. So we're going to subtract the 3x with its like term, subtract the 2x with its like term, and add 1x squared over. So let's see what we get here. So we're going to have an x squared, and then all of these terms combine, the 2's cancel, so negative 3x minus 4 equals 0. Again, now we have a quadratic, lots of ways we can solve. This one does factor, x negative 4 and x positive 1 to get us our two answers. Negative 1 there, and positive 4. Good, so good review of rational equations.